Polygon. The word means many angles, but it ignores one attribute: straight sides. Polygons are all around us. Learning about these basic plane shapes helps you understand about geometry. This video lesson will teach you to identify and define polygons and regular polygons. Find the sum of interior angles of regular and irregular polygons. Find the interior and exterior angles of regular polygons. Let's start. What is a polygon? A polygon is a plane figure that closes in a space using only line segments. If it must use only line segments and must close in a space, the polygon with the fewest sides has to be the triangle, 3 sides and interior angles. Polygons have no upper limit to the number of sides and interior angles, so mathematicians say n-gon, after the familiar names we use for common polygons. Let's take a look at the vast array of shapes that are polygons and see how many sides each polygon has. When describing a polygon, you can also use a shorthand, like this: 19-gon, 23-gon. Most mathematics students, teachers, professors, and mathematicians use n-gon for any polygon with more than 12 sides and angles. There are many different types of polygons. A convex polygon has no interior angle greater than 180 degrees. It has no inward pointing sides. A concave polygon has one interior angle greater than 180 degrees. A simple polygon encloses a single interior space, boundary, and does not have self-intersecting sides. Complex polygons have self-intersecting sides. An irregular polygon does not have congruent sides and interior angles. A regular polygon has congruent sides and interior angles. Let's take a closer look at regular polygons. A regular polygon is where all sides are the same length and all angles are also all the same. Next time you're in a car, take a closer look at a stop sign. A stop sign is an example of a regular polygon with 8 equal sides. No matter which way you're looking at a regular polygon, you wouldn't be able to tell which way is up because the angles and sides are all the same. A triangle that has all sides and angles the same is called an equilateral triangle, or regular triangle. A quadrilateral that has all sides and angles the same is called a square, or regular quadrilateral. A pentagon that has all sides and angles the same is known as a regular pentagon. An n-gon that has all sides and angles the same is called a regular n-gon. Check out these regular polygons. Do you notice how all the sides and angles are the same no matter which way you flip it? Let's take a look at the interior angles of polygons. The interior angles of polygons are the vertices, or inside corners, created by endpoints of line segments. Connecting all the vertices inside a simple polygon without crossing any lines creates triangles. Each triangle adds to 180 degrees, so one way to find the sum of interior angles is to count the number of dividing triangles in each polygon. For example, a triangle, of course, has one triangle that is 180 degrees. A quadrilateral has 2 triangles. 180 degrees times 2 equals 360 degrees. And a nonagon has 7 triangles. 180 degrees times 7 equals 1,260 degrees. However, that can get clumsy after a while. You can instead use a formula for the sum S of the interior angles. You need to know the number of sides, n. S equals n minus 2 times 180 degrees. Try it yourself on a triangle. S equals 3 minus 2 times 180 degrees. S equals 180 degrees. That one was easy. Now try it on a nonagon, a 9-sided polygon. S equals 9 minus 2 times 180 degrees. So, S equals 7 times 180, which is 1,260 degrees. This formula works for both regular and irregular polygons. What about the interior angles of regular polygons? All interior angles in a regular polygon are equal or congruent. Once you know how to find the sum of interior angles, you can use that to find the measure of any interior angle, angle A of a regular polygon. Take the same formula and divide by the number of sides. Angle A equals n-2 times 180 degrees divided by n. Let's try it out for an equilateral triangle by plugging in 3 for the number of sides, n. Angle A equals 3 minus 2 times 180 degrees divided by 3. Subtract and multiply and we get angle A equals 180 degrees divided by 3. Angle A equals 60 degrees. What about a regular nonagon with 9 sides? Let's plug in 9 for the number of sides, n. Angle A equals 9 minus 2 times 180 degrees divided by 9. Subtract and multiply and we get angle A equals 1,260 degrees divided by 9. Angle A equals 140 degrees. This formula can be rearranged like this. Angle A equals 180 degrees minus 360 degrees divided by n. Both versions will give you the same answer. Notice the second part of that version of the formula, 360 degrees divided by n. We are going to use that next. Now let's take a look at the exterior angles of polygons. The number of interior angles and exterior angles of any polygon is the same. A triangle has 3 exterior angles, a square has 4, our nonagon has 9. An exterior angle is the angle created outside the polygon between one side and a line extended from an adjacent side of the polygon. The interior and exterior angles will always add to 180 degrees, so they are supplementary. On irregular polygons, you have no way of knowing the measure of exterior angles. On regular polygons with insides, you can use a formula to know each of the shape's exterior angles, since they will be congruent. Exterior angle equals 360 degrees divided by n. In an equilateral triangle, the exterior angles come out like this. 360 degrees divided by 3 equals 120 degrees. Our nonagon does this. 360 degrees divided by 9 equals 40 degrees. Look back at the second version of the formula for finding interior angles of regular polygons, which we wrote as angle A equals 180 degrees minus 360 degrees divided by n. Now, you can see that the two formulas make sense together because one finds the supplementary angle of the other. In any regular polygon, every interior angle is supplementary to every exterior angle. Lesson summary. You should now be able to identify and define both a polygon and regular polygon, find the sum of interior angles of regular and irregular polygons, and find the interior and exterior angles of any regular polygon. You can use formulas to find the sum of interior angles for any polygon and to know the exact measure of both interior and exterior angles for regular polygons.